Hey guys, I'm back. We're going to do some more ionic compounds, but in part 2, we're going to look at how to add subscripts to write a chemical formula. Are you ready? Let's go. Okay, so first of all, when you're going to write formulas for ionic compounds, you need to know that all ionic compounds are neutral, which means that the number of electrons lost by the cation has to equal the number of electrons gained by the anion. On our last video in our last paper, we saw K wanted to lose 1 electron, so it became K+. Cl wants to gain 1 electron, so it became Cl-, so we have these opposite charges together. Or we had Ba wants to lose 2 electrons, so it's Ba plus 2. Oxygen wants to gain 2 electrons, so it's O minus 2. And again, we've got opposite charges attracting and charges canceling. We also had things that had multiples. If you have K with O, K wants to lose only 1 electron and oxygen wants to gain 2 electrons. So we're going to have 2 of the Ks so that we can lose enough electrons so that the oxygen can gain them. So let's look at how to write compounds or write formulas with this. In a chemical formula, the subscripts represent the number of ions of each species needed to make sure that the charges cancel. So how many of each thing we need? So in our previous example, I said KCl. You need 1 K and 1 Cl. So your compound is just going to be KCl. But if we had something like K2O, K plus, O minus 2, K plus, we're going to have K2O to show that I need 2 Ks to balance out the charges on the oxygen. So look at your worksheet on the side called formulas, and we're going to write some chemical formulas, starting with number 1 is BEF. So you've got the BE and the F that are written right there. I'm going to write them bigger, but you're just leaving those letters written as they are on your paper. So look up at the periodic table and find BE. Did everybody find it? It's in group 2, which means that it has a plus 2 charge. Okay, now look at F. Find F, group 17. -1 charge. Add those charges onto the letters. So yours is going to look a little bit more like this. You will have Be plus 2 and F minus, just like that. Okay, so now I notice that I'm going to need 2 fluorines, so I can have 2 -1 charges to cancel out the charges on the Be. So I'm going to crisscross, that is, take this 2 and move it down there. 2, and take that 1 and move it down there, 1. But we don't really ever have to use 1s when we need 1s. So you don't even have to write that at all. So what you're left with is BEF2. So on your paper, what you're going to write, because your paper is just what's in that little box, all you're going to do is add a little 2 right there behind the F. So we have BEF2 to show that I've got 2 F minuses to cancel out my plus 2 on BE. Let's do another one. The next one we have is LiNO3. So Li, find Li on your periodic table. Hopefully you're seeing it's got a plus 1 charge. And nitrate, NO3 is nitrate. Have you memorized that ion yet? Well, even if not, look on your common ions chart or on your flashcards and notice that nitrate, NO3, is -1. So I'm going to write it again kind of big so it's easy to see. So we know that lithium is +1 and NO3 is -1. Since those charges cancel, +1, -1, all by themselves, you don't have to write anything. You can just leave it exactly as it is. So let's look at the next one, SN plus 4, SO3. So for SN, they're giving you the charge +4 because the metals, mostly the transition metals and underneath the stairs, they have kind of varying charges. So if they ever tell you a charge like this, then just say that's the charge. You don't have to look it up on the periodic table. If they give you the charge, that's the charge. We also have SO4 -2. And oh sorry, that's not even right at all. That's SO3. And you'll recognize that hopefully from your common ions chart. SO3 is sulfite, and -2 is its charge. So now we're going to crisscross the charges. But the thing is, it looks like, since this is a +4 and this is a -2, I'm going to need 2 of these -2's to give me a -4. So I'm not actually going to crisscross this time. I'm just going to give myself 2 of these SO3s. So I'll put a little 2 down there. And I won't need anything for the 10 because I've already got a +4. Well, here's the trick then. It looks like I've written SNSO32 as if I need 32 oxygens, which is not at all correct. So I'm going to put a parentheses between the 3 and the 2. So if you look at what's written on your paper, you're going to write this, -2, 2. Okay, let's do another one. This time we've got MgC2H3O2. So I will write it again big, MgC2H3O2. So you know that Mg is +2 because you can see it on the periodic table in group 2. You know that C2H3O2 is called acetate and it's a -1 because I know that you've already memorized all of those ions. Remember, daily quizzes starting Monday. So what we're going to do is notice that I'm going to need 2 of these acetate ions to have the same charge as the magnesium. So I'm going to put a parenthesis around the acetate and put a 2 there to give me 2 acetates. Make sure that you put a parenthesis. So on your paper, oops, let me undo that. On your paper, if you have this and you just put a 2 right there, it looks like you have 22 oxygens and 3 hydrogens and 2 carbons, and that's not at all what you want. Instead, you want to have 2 groups of acetate. So you'll put a parenthesis first, and then you'll put your 2. Let me see if I can get it fit back right again. Next we have AlCl3. Let me see if I can put that in there right. Wow! There it is. All right, AlCl3. Let's do another one. AlCl. And so aluminum is +3 because the periodic table and my common ion sheet tell me so. And chlorine is -1. So that means I'm going to need 3 of these chlorines to balance out the charge on the aluminum. So I'll put a 3 there. The trick is, though, oops, let's see. Zoom in big. If I put a 3 here with a parentheses, that's the exact same thing as putting a 3 without the parentheses, because a chlorine is just a single atom. So I have 3 chlorines with the parentheses or 3 chlorines without the parentheses. I don't really necessarily need to have a parenthesis there. I only need a parenthesis if it's one of those common polyatomic ions, something that's got more than one element. Like if it were ClO3, 3, then I would need 3 chlorates rather than just 3 chlorines. But that's not what we have here. We just have AlCl3. Okay, I will zoom back out and tell you one more thing. You can put, so far we've put the subscripts only on the anions, but you can put the subscripts on the cations as well. I'm going to zoom this all the way out and move it up there and do one where the charge will be on the other, such as number 7 has NH4 and S. So know from your common ion sheet that NH4 is +1 and sulfur from the periodic table is -2. So you're going to take your NH4 and multiply it times 2, which means essentially you're going to take that 2 and cross it down here. But be careful about that because you don't want to have 42 hydrogens. Let's see if I can put that right. Okay, let me draw that again. Add in that -2. So I'm going to put a parenthesis before I put my 2. And so then I end up with something like NH4-2S. Okay, so now I want you to go through that entire formulas page and write subscripts for each of those compounds. Make sure you include parentheses before you write the subscript for any ion that has more than one atom or more than one element in it. All right, you're on your own. Good luck.